In this example, we're going to use RStudio to calculate the confidence interval for a slope in a simple linear regression scenario. A computer manager needs to know how efficiency of her new computer program depends on the size of incoming data, and efficiency will be measured by the number of processed requests per hour. So the response variable here is the number of processed requests, y, and the explanatory variable is the size of the data in gigabytes. So if we want to calculate the confidence interval, we first need to run in our data. So x, again, is the size of our data in gigabytes, and y is the number of processed requests. So if we run this in, and then we calculate the linear model. So this is LM, y versus x. So we need to do this first, and we need to call it something like mod. Then to look at the summary information, just to get the point estimate, we can see that our point estimate will be -3.3941, and that the intercept of our line will be 70.16, but we don't really care about that so much. If we're going to calculate the confidence interval for the slope, all we need is this estimate value, the standard error, and a t-critical value from 9 degrees of freedom. So there's 11 observations, and since we only have one explanatory variable, it's n minus k plus 1, or n minus 2 in this case. And so we had 11 observations minus 2 is 9 degrees of freedom. So we could look up a t-critical value, just take this plus or minus our t-critical value times our standard error and get the confidence interval. Or we can make it so much easier on ourselves and just do the confint command. So CONFINT, and it actually comes up here as one of the commands. I'm going to put in mod, this is the object that it wants, and the level of confidence. So in this example, let's do a 95% confidence interval. And sure enough, I get a confidence interval for my intercept and my slope. Again, we don't really care about the intercept so much. We care mostly about the slope. So what this is telling me is that on average, with a 1 gigabyte increase in the data size, the number of requests should decrease by 4.44 to 2.35 according to the 95% confidence interval. So it's going to change between 4.44 and 2.35 for the number of requests, with a change in our explanatory variable, which is the size of gigabytes. So this confint command is really helpful. Once you take the linear model, you can simply just use this. You can also change the confidence level to something else if you want to. So if you want a 90% confidence interval, you could calculate that. 99, you can just simply change the level. So this is an easy way to calculate the confidence interval for your slope.